Hi guys, here is an attempt at doing similarity again, okay? So before I actually go ahead and do the notes here with you guys, I wanted to maybe try to explain similarity in a different way, because a lot of you guys at this time, like, see these two erasers, right? I know they have different letters or wording on them, but they're the same. I got them in the same package, right? Their lengths are the same, their widths are the same, their heights are the same. So we can say that these are the same. These are congruent. So if I were, let's see, to take my little sticky note, I can say that this eraser is congruent to this eraser. Okay, and if I wanted to get fancy and give it a name like A, B, C, D is congruent to D, E, F, G. Okay, what you guys are doing right now with triangles, or what you guys were trying to do, was do this. You guys were doing this for the example of side, 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 right? And we were like, it's wrong. And the reason why it's wrong is because these are congruent. This mark tells me that this side here is the exact same length as this side here. And this is true in a case like this, where we have these two erasers and they are the exact same. But in our case, we don't have that. Okay, in our case, the reason why we have the scale factor is because we have something more like this. Okay, so if I get rid of that. And I know that these are not perfect, okay, because my daughter's been using them, but this is the best example that I can come up with, okay? These are both erasers, and when it was brand new and didn't have these scuff marks, right, they had the same angles, they had the same dimensions in terms of the angle measurement here, the angle measurement here, the angle measurement here, 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 here. Okay, do we agree? Most of these pink erasers look the same when they're brand new. But can we say that these two are the same? No, right? If I give this to one student and if I give this to the other and say, I gave you guys the same thing, you guys are like, no, they're not. This one is bigger. I want that big eraser, right? I don't want that little eraser. So what can I do? You're telling me that the angles are the same, but that these two things are not the same, okay? So what we're talking about in this case is similarity. Okay, they are similar. And that is where our new sign, just that little squiggly, comes into play. Because eraser A, B, C, D is similar to eraser D, E, F, G. Okay, so if I were to trace these out, okay, and I'm going to pretend that I'm tracing these, obviously not drawn to scale. Can I say that this side is congruent to this side? No, I can't, right? That doesn't make sense. This side is congruent to this side, and this side is congruent to this side, but this side is not congruent to either of those sides. So it would have different markings. Does it mean that these two are not similar? No, it doesn't. These are similar, right? They are similar, but they are not congruent. So I hope that helps, right? Similarity versus congruency. Okay? Do we get that picture? Congruency, similarity. Okay, well, I hope that helps. All right, so now I know some of you guys have watched the video and some of you guys have not watched the video with the other guy teacher. The reason why we had done the video was, or sent that video, was because we weren't feeling too good. And as you guys saw, Miss Ramos had lost her voice yesterday, and today she was just feeling a little bit better. And this is what we have. So I'm actually going to go through it with you guys in hopes that you guys understand better. And like I said, some of you guys have had your homework checked, some of you guys have not. And for those of you who have, you have heard that we want you to make sure that you copy this as we have it here. And for full credit on the assignment, we want you to be able to turn it around and give us 2 examples of whichever one. You can do one of side, 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 and one of side, angle, side. You can do of one angle, angle, one side, angle, side, or whichever combination you want, just to prove to us that now you understand what similarity is. Okay, so let's go ahead and start with the notes part. And we have, sorry for mine's really ugly because the printer was running out of ink. Side, side, side. Similarity is if the 3 sides of one triangle are proportional. Proportional. Sorry that I write really big. Proportional to the sides of another triangle, then the triangles are similar. Again, that word similar, right? That's squiggly. Okay, so let's go ahead and do an example for side, side, side. Some of you guys have the example that I did with some of the periods here. I have another example that maybe is going to be either a little bit more clear or just add to your knowledge, okay? So the first thing that I'm going to do is I'm going to draw 2 triangles, and you're going to notice that my triangles are not going to be the same size. Now that doesn't mean that they are not similar. And you're going to notice that my markings or that my numbers are going to be different, okay? So I'm going to name this triangle A, B, C, and this triangle D, E, F. Now, I'm going to give some information. Okay, now that I have that information on my triangles, I need to figure out whether or not these are similar, okay? And in order to do that, I need to set up my scale factor or my ratios, okay? So I'm gonna write the word scale factor. I'm gonna leave room here for my reduction, okay? And now, some of you guys are like, well, how do I know which side goes with which side, right? Do I just guess? Do I follow the letters? Well, you're not always going to be correct if you follow the letters, because sometimes they don't put them in the correct order alphabetically on purpose. Here, let's see. Of these 3 numbers, which one's my smallest number? 12. Okay. Which one of these 3 is my smallest number? 6. Okay. And if I'm going numerically, which is my next number on the number line? 16. And on this side, 8. On this side, I have 18 left, and here I have 9. Now, most of you guys already saw the pattern, right? But let's pretend that we didn't see it. And we're gonna go ahead and set up our proportions. And this is how we were doing it in class, right? We said, well, which one's old, which one's new? If it's not specific, remember we said the one on the left is our old, and the one on the right is our new, okay? And let's set up our green proportion, which is 12 over 6. Next would be my purple proportion. Sorry, actually, I didn't follow my own rule, right? New over old. 6 over 12. 8 over 16. And 9 over 18. Now again, those numbers are not the same, but I can reduce, right? So I have my handy dandy sticky notes here. Can we reduce? That's something you should ask yourself, and in this case, we can. Remember, I was doing this on the board. What number fits into both of these? Actually, 6. So if I were to take 6 and divide it into both of these numbers, I get 1/2. What number fits into both of these? And actually, I wrote my number wrong, trying to get ahead of myself, huh? This is a 16. Okay, 8 fits into both of these. And it reduces also to 1/2. 9 fits into both of these. And that's also 1/2. Now, remember, some of you guys were asking, well, where are you getting these numbers from? Or am I always going to take that top number or the bottom number and try to divide it in? No, we're looking for our greatest common factor, right? These numbers are the greatest common factor, okay? So we remember that from, I don't remember exactly, but probably around maybe 6th or 7th grade when they were teaching us about reducing fractions. Okay, so remember, we never leave anything behind. We always just keep building up on math, okay? So we reduce by the greatest common factor and we end up with 1/2 for all of them. Is this all the same? Yes, it is. So once these are reduced to 1/2, 1/2, 1/2, we can say, check, these are similar. Happy face. The scale factor is 1/2. Now, a lot of you guys were having trouble with the statement as well, similarity statement. Now, that just tells us that you can it tells us that the triangles are similar and what is corresponding to what. So triangle ABC, and I'm just going to go in that order. ABC is similar. Notice I just have the one squiggly. Now, AB, that was my green. DE is my green. Then I went BC, EF, EF. Oh, and I forgot my triangle. There we go. Okay, another way that I was showing another student is I can just pick shapes, right? Circle, square, and triangle, and then I can say what corresponds to what. Well, the A and the D correspond, the B and the E correspond if I'm following my green, purple, blue pattern or path. And then I can just decide to go circle, square, triangle, circle, square, triangle. Okay, whichever way makes it easiest for you. All right, so the next one, side angle side. And this one says, if the measurement of the two sides and one angle of two triangles are proportional, then the triangles are similar. Well, we're talking about proportion, we're really talking about the sides and the angle. Remember, the angles have to be congruent, okay? But the sides have to be proportional. Now, let's do our example, okay? So for this example, I have two triangles again, and I hate the fact that I can't see my lines. But I'm glad that you guys have better copies. Actually, I don't like that triangle. It looks too much like the old one. See why this eraser is not perfect? Because I keep using it. Okay, so there are my triangles, and I'm going to use my same lettering: A, B, C, D, E, F. Okay, and the difference here is that I'm going to actually have an angle. This is going to say 50 degrees, and here I'm going to have 50 degrees. I'm going to have a 12 here, and a 24, an 8, and a 16. Now, we have an angle. Oh my gosh, it's the end of the world. No, it's not, okay? Remember, we need to have side angle side. That's what we're trying to do here. So, again, with the numbers, which one's the smallest number in terms of like numerically, right? We have the 12 on this side. The smallest number is 8. Okay, then we have our lovely 50-degree angle, and it's also a 50-degree angle here. And then we have our 24 and our 16. Now, what the coloring is gonna do is help us make sure that we're putting our correct scale factors, okay? So that we're not just putting them with the numbers that we think that they go, but that we're a little bit more sure, okay? So here I'm gonna have, again, my old over my new, and I have my new over my old. Sorry guys, I keep messing myself up. 8 over 12. And I have 16 over 24. All right, now I don't have 3 like I did over here. And why is that? Because I have my angle. I don't need to set a proportion for my angle because I know numbers, right? That 50 is congruent to 50. That's going to be true. 50 is equal to 50, congruent to 50. So I just need to prove that these two sides are similar in order to have side angle side. Okay, so can I reduce? I have my little handy dandy sticky note, and yeah, if I look at 12 over 8, I can reduce by the greatest common factor of 4, which gives me 3 over 2. I can reduce by 8 on this side, which also gives me 3 over 2. So are these triangles similar? Yes, they are. So what am I going to do? It went to 3 over 2 and is 3 over 2. Check. These are similar. Happy face, because math is fun. And now let's do our congruency statement. Okay. Triangle. And look, A, B, C. I went from my pink to my angle to my purple. Okay. Pink to angle to purple. So what does that mean? D, F, E. Now you see these are not in order. That's on purpose, right? We do that. Sometimes the book is going to do that. The district is going to do that. They're going to make sure that things are not always in order because sometimes we get a little lazy and we're trying to do only A, B, C, D, E, F. No, they're going to throw a little monkey wrench in there and try to make sure that you know how to name your angles. Okay, for this next one, Miss Ramos and I were talking today after school, and some of you guys were having a hard time with this definition. So if you have a handy dandy whiteout, you can go ahead and actually white this out and fill in with this following statement that I have here, okay? When two triangles have corresponding angles that are congruent, the triangles are similar, okay? Now, if we remember triangle sum theory, if two triangles are similar, then when we do triangle sum, the third one is automatically going to be similar, right? So that's why we only need 2. So the example that I have here is going to be maybe a little bit more complicated looking than the ones that I have on this side, but that is because this is a little bit simpler, I guess you could say, because all we need to do is see that the two angles are similar in order to say that these triangles are going to be similar. So I'm going to go ahead and draw here, and I'm going to say this is Q, S, R, V, and T. Okay, I used different letters, and I used something that's kind of like touching each other, and now you guys are like, up, here she goes, making things complicated. No, I'm not, guys, okay? So what is that one thing that Miss Ramos and Miss Corrales kept talking about, that things don't go away? Well, things don't go away, okay? So what is this? These are vertical angles, okay? So look, we know that this box means 90 and this box means 90, and these vertical angles are going to be congruent. So look, angle, 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 similarity. Now, if we knew what this was and we did triangle sum theory, right here would be the exact same thing as here. But we don't have to do all that. We already know that they're similar because two angles are similar regardless of what this middle measurement is, because we know that that's 90. Okay, so how do we name or make this statement? Let's see. I'm gonna use circle, triangle, and a box. Okay, and let's see. I'm gonna go from my 90-degree angle to my vertical angle to nothing. Okay, so triangle SRQ is similar to 90-degree angle V, triangle V, and then a vertical angle R, and to the nothing angle T. Okay, so remember, vertical angles don't go away. These are vertical angles. Okay, so I hope that this helped you guys, and remember, if you want full credit on the homework, you don't only have to come up here and copy this, because anybody can copy it, right? It doesn't mean that you understand it. Go ahead, look at it. Hopefully you understood this, and you can turn this over. Choose to do 2 examples on whichever ones you want, and you can show them to me, take a picture, send it on Remind, and we'll go ahead and give you credit for that as homework, okay? Now, I did have a couple of people ask me about the homework, and we actually sent you guys the answers, not because we didn't want to help you, but because sometimes it's easy to work backwards, okay? And in terms of these in the back, some of you guys were having the question as to, well, I don't know what it is, or I don't know if it's similar. Remember, read the instructions, guys. Here it tells you the triangles in each pair are similar. So they're telling you that they are. You need to give me the value that's going to make that sentence true. Okay, so I'm going to go ahead and do... Oh, wait, what happened? Okay, well, I'm going to stop because my camera stopped working, guys. See you guys tomorrow.